I am from KIT University, from School of Biotechnology. I'm happy to be here at the Faculty Development Program, and it is my pleasure, and I thank Dr. Mahinder Pal for inviting me and sharing my experiences of being an entrepreneur for the topic for the FDP, which is uh, entrepreneurship, innovation, and incubation. So I'll share my presentation. Okay, so I hope you all can see. Now my journey from being a researcher to an entrepreneur has been a very good learning experience. I am a small-time researcher, and I love my pipettes and I love my shake flask. I like my microbial cultures. Coming from a zoology background from Delhi University, doing PhD, did my postdoc in Europe, and then started School of Biotechnology at KIT University, and loved teaching, interacting with students. I was very happy in my own world. So my experiences from workbench to enterprise is what I would like to share with you. And I hope you all can get some inspiration or motivation to even start your own entrepreneurial journey. So I'm going to present on from workbench to enterprise, lessons from my entrepreneurial journey. So I'm going to tell you three stories which I have uh, I'm going to connect to it. So I hope uh, they are of good use to you to become future entrepreneurs of tomorrow. So before I start anything, I would like to acknowledge all the collaborators and researchers, people who have worked a lot for motivating me going into entrepreneurial journey. So these are all the people. This includes collaborators from India, collaborators from out of India, from Europe, my PhD students, the incubation center which I'm working at, my partners in business, and of course funding agencies of different funding agencies who have supported us in my entrepreneurial journey. So basically, I am living on the east coast of India, where Chilika Lake is a very famous backwaters. It's also famously called as Chilika Lagoon, which I use for my research work because it is a highly biodiverse region. And it's a beautiful region where you have dolphins, you have a bird sanctuary, you have Siberian cranes and birds coming from Russia every winter. And it's a treat for ornithologists, for zoologists, for people who love nature, etc. So keeping my love for nature, I also chose this site for my doing my research, which I was interested to do, and I was wanting to study this environment for its biodiversity because of microorganisms. We all know that microorganisms are very beneficial, and in the biotechnology sector, microorganisms are extremely important to develop new technologies, etc. As you already know, microorganisms can be both good as well as bad. We all know which are the good microorganisms, and we have the bad ones also, which we are currently having in our environment. And one of them is what we are suffering because of the pandemic. The COVID is also a microorganism, but in the bad category. So nevertheless, researchers have to study them, and natural ecosystems are the ones where these microorganisms are found. So I'm trying to work for the good microorganisms and trying to find out new strategies, how to use them for developing biotechnological solutions. And my uh, area of research also focuses on using these microorganisms for developing technology which can be used for commercial advantage. And of course, it answers an underlying problem which we generally face. I also work on another freshwater ecosystem. So Chilika Lake is a brackish water ecosystem. It's a slightly saline ecotone region, estuarine. So it's not freshwater. But Loktak Lake, which is the only floating lake in Asia, it is in Manipur, and it's also a biodiversity hotspot which sustains a lot of livelihood. So I work on microbial isolation of microorganisms from natural ecosystems. We have isolated several unique novel microorganisms, but I also not only focus on the microbiological aspects by isolating them in laboratory, but I also work on using culture independent techniques like using bioinformatic techniques for studying microorganisms, metagenomics, and using genomics and proteomics platforms to identify novel microorganisms and then use them for development of technology. So we have isolated several microbes from Chilika Lake and from Loktak Lake, and these are some of the pictures of these microorganisms. Chilika Lake is an interesting case study as well, because it is having a lot of ecological problems. One of the problems is the global warming. And the global warming is causing a lot of changes in the environmental patterns. And the major problems which the lake is undergoing is that almost every year from 1999, it is subjected to several types of cyclones. So this year also we had a cyclone. It was named as Amphan. Well, it did not do much of damage in Odisha, but it did a lot of damage in West Bengal and associated areas. But we had a cyclone in last year, which was called as Fani, which did a lot of destruction. We had one cyclone in 2013. We had Phylin in 2013, which I witnessed. It was one of my first cyclone, and it was a very severe cyclonic storm. And then you had another cyclone coming up in the next year, which was called as Hudhud. And all these cyclones, they caused several ecological problems in Chilika, and we worked on some invasive plant species in the lake which grow before the cyclone. So the cyclone caused several invasive species to grow in the lake, and this caused the biodiversity of the lake to change, which means the microorganisms present in the lake, they change according to the change in the global climate pattern. Now, from this research work which I was doing, so I was deeply into the research work of Chilika Lake and trying to understand microbes and trying to gain a lot of information. And we have a Chilika Development Authority which manages the Chilika Lake from the government of Odisha. And they came up with a problem that we have this invasive weed which is called as Phragmites carca, belonging to the Poaceae family, that's the rice family. It is growing so fast in the lake that it is almost eating up the lake and destroying its fisheries and other animals and plants. So they asked us to find a biotechnological solution for solving the invasive weed which is proliferating at a very high rate and shrinking the biodiversity regions. And this is impacting a lot on the livelihood of the communities which gain commercial advantage from the produce which is produced from the lake. So I had a group of students, and those students, I gave them this problem. Okay, you take this problem and try to solve it. So being a teacher, being a researcher, our main area of interest is looking for problems. Where do I look for problems? And here the problem was given to me by the Chilika Development Authority. So these 4 students, they said, okay, can we use this invasive weed for making handmade paper? Ultimately, the weed has cellulose and it can be converted into pulp. And whether it can be made into an alternative livelihood for local community. And they just went into it, and they wanted to use enzymes, and they found some enzymes, celluloses. They wrote a grant for MSME, and it got funded. they bought machinery, and they made handmade paper. So this is one of the first examples I'm telling you, where a problem which was in front of me and it was presented to me, and we tried to use that problem to create a solution. And this solution can be turned into a entrepreneurial venture, which will enable our fishing farmers which are in and around the lake to develop livelihood apart from fishing, because fishing is the only livelihood which they have, and they don't have any other means of livelihood. So biologically engineered paper was produced using enzymes. They even got a DST Lockheed Martin award, and they were supported by MSME. So a problem was taken up and a solution was obtained. Now I come to the another part of what I'm trying to explain my entrepreneurial journey. We all know that world is undergoing through a lot of energy demand. The world population is increasing, the energy consumption is increasing. We have new and new challenges almost every year. The landscape keeps changing. This year we have, last year we had a big cyclone. This year we have a smaller cyclone. This year we have a pandemic. It's a worldwide problem. And one of the main problems, apart from other things, is the need for energy. So this energy is important for us because we need to use it for our transportation. We need to use it for our cooking. We need to use it for our industries. And so it's a lot of work we have to do, which needs a lot of fuel. So the energy consumption keeps on increasing. It doesn't decrease at all. And there is no one chance that we can skip it. So this year we had lockdowns. We had less consumption of fuel. There were no cars, nothing. But you can see the diesel prices, the petrol prices, they are still rising. And we are going to bear the brunt of it. But what is the solution? We can't just keep crying that, oh, there is a problem, but we need a solution. So the world energy predictions from different sources show that the consumption by source of different types of fuels is going to increase in the next 20 to 30 years. The projections have already been made till 2020, 50. And a lot of environmental impact assessment projects that world energy consumption is going to grow by 48%. That's quite a big jump which the world is going to see. And this is going to impact global warming even more. And that's why there is a lot of concern. Most of this growth is going to come from countries where the demand is driven by strong economic growth, and India is one of them, especially in Asia, and China is also there because we are having more than half the population of the world. So what are the results? The concerns are pollution, climate change, depletion of resources. These are things which you already know. So we do have a solution. We can make alternative energy sources like biofuels, and there are first generation, second generation, third generation, fourth generation biofuels which have been known. And this is all theory. First generation comes from sugar, starch, vegetable oil, animal fats, which are consumables. And since we need to eat them, we cannot use them for fuel. Second generation biofuels come from non-food crops like cellulosic biofuels or any kind of oils or animal fats, but which are non-food. They can come under second generation. Third generation focuses on algae, and fourth generation focuses on genetically engineered microorganisms. So one of the energy fuel, which is diesel, it's very important because industries run on this particular fuel, and Rudolf Diesel was the first one to identify it. And there are several properties of diesel like calorific number, cetane number, viscosity, flash point. All these are important properties of diesel which make it suitable as an industrial fuel. So if we need to replace diesel, then we need a fuel which will replace diesel, but it should have all the features which are shown here on the slide. So what exactly is biodiesel? And biodiesel is nothing but a vegetable oil or an animal based fuel consisting of long chain alkyl esters. So technically, you can see here the structure of biodiesel. And diesel is a hydrocarbon. It only contains hydrogen and carbon. It does not contain oxygen. So it does not burn completely. But biodiesel, it contains oxygen. Here you can see there is an oxygen molecule here, and that's what makes uh, biodiesel different from diesel, which is a hydrocarbon, because it does not contain any kind of oxygen. And biodiesel, because it burns completely to combustion, it does not produce any kind of black smoke, or it doesn't cause pollution, etc. So how can biodiesel be made? It can be made from vegetable oils or animal fats, whether it is edible or non-edible. Now, edible we cannot use, because edible we want to use it for our consumption, and food versus fuel debate can ensure. So we want to use vegetable oils which are non-food ones. So there is a trans-esterification reaction. Most of you must be knowing this. Triglyceride can be reacted with a catalyst, and it results in a methyl ester and glycerol. And the fatty acid methyl ester, this particular structure is the biodiesel. So this process converts vegetable oil into a less viscous structure, which is called as fatty acid methyl ester, which is also called as biodiesel. And there is a side product called glycerol. So you can use edible oil, but we are not using any edible oil. You can use algal oil, but we are not focusing on algal oil. In my story, we are going to use non-edible oil. So we are focusing on waste cooking oil. So we are not focusing on any kind of plant sources. Jatropha is one of the more famous ones. Pongamia is there, but we are focusing more on waste cooking oil, which is used cooking oil. And why do we want to use waste cooking oil? Because food versus fuel debate occurs. We don't want to compromise food, and biofuels have to be grown. If you are using plant-based fuels, then you need to grow them, and you need land to grow that. And so, well, whether you will grow land for fuel or for food, that's an important thing. So waste cooking oil, when heated to a very high temperature, results in production of several carcinogenic compounds. We already know that we should not excessively heat the oil which we use for cooking, especially when you are frying French fries, or any kind of vegetables, or even different types of processes. So why waste cooking oil? Because it's always available. There is no need for any land to grow, and there is no upstream processing required, because the material is already available. So our mission was to reduce, reuse, and recycle in accordance with waste to wealth scheme, where low cost biodiesel fuel can be produced in a zero waste green chemistry reaction, which is more commercially viable and cost effective in a sustainable process. So we wanted to promote environmental stability by utilizing waste. So waste to fuel, and we wanted to create cost-effective clean fuel, which is biodiesel or light diesel from waste cooking oil or used cooking oil. So what was the technology? So we collected a lot of waste cooking oil from in and around the university. We filtered it, tested the quality of the waste cooking oil. So there are several parameters on which you can test it. Pre-treat the oil and process the oil using trans-esterification reaction, which I showed you earlier, and separated and settled, and did the entire green chemistry reaction, and then did downstream processing and then storage. So where do you get that oil from? You can get it from all the eateries which are in and around. hotels, etc. They all produce waste cooking oil and they just want to get rid of it. So I had given this problem to one of my another student who was doing his dissertation under me, and I told him that, okay, your job is to collect waste cooking oil from different eating establishments, and then you are going to make biodiesel out of it, and you're going to check whether the biodiesel is any good and whether you can use it for anything further. So we got the biodiesel from local processing factories, and we developed a team, and we call this team as Indhan Bioenergy, and we got grant from MSME. We got patronization from the university itself, and I took some students which were doing project work under me. And this is Rahul Chatterjee, one of my student, whom later on I will tell what we did, something else along with this. So this was the lab scale production of biodiesel, where we used waste cooking oil and we tried to convert it into biodiesel, and we were able to do it. He was able to do it for his for his dissertation, but that was not all we wanted. You can make a nice dissertation and then put it in the library and then say, okay, you know, I did it. But then if you are having an entrepreneurial thought that no, I want to bring it to the common man, I want that the product should be made at a larger scale, then you have to work slightly more harder. So we tried to bring grants, and we tried to get grants from MSME. We got grants from KIT University. We got grants from NSTDB, and we were able to develop a pilot scale facility, 100-liter facility, where we had different units for the different green chemistry reactions, like transesterification was there, the catalyzation unit was there, the washing unit was there, and the final product would be produced in the end. So this was how the waste cooking oil from the restaurants looked like. And believe me, all the roadside vendors who sell you food and golgappas and papdi chaat, etc., they don't buy good oil which is 100 rupees a liter from the supermarket. They are going to buy, not buy even, they just get it for free, used cooking oil from big restaurants and big hotels, and they use that oil to make your golgappas. And that's the reason why you get an upset stomach when you use oil from these roadside, when you use any kind of food product from these roadside eateries. So this bioenergy facility was made in the university at Kalinga Institute of Social Sciences, which is a university now. And a pilot scale study was conducted. We have been doing this since 2014, and it's still ongoing. Our objective was to create a waste management and a clean renewable energy generation process. And this clean energy made clean fuel. And how do we know that the fuel which we have made is any good? So a lot of testing was done according to ASTM standards, and those have to be tested in HPLC, and we sent it for analysis in the School of Mechanical Engineering, where they have fuel testing instruments, and they can check all the parameters of biodiesel so that it can be compared in its efficiency along with diesel. So when you burn biodiesel, you see that there is no smoke and there is no soot which is produced, whereas diesel will always produce soot, and biodiesel will always burn for a longer time because it has oxygen molecule. It will undergo complete combustion. It can be used for stove tops, for generators, and also in diesel engines. So a lot of testing was done on this, and we compared it with kerosene also. And the outcome was that the reduced amount of smoke was being generated. So why did we do such an initiative? The problem. So you have to always understand, an entrepreneur always deals with a problem. The problem can be very small. It need not be a super technology or anything. The problem is always a small problem, and you can address that small problem. And you have to find a solution which is easy to do, which is scalable, and you can do the maths later on, because if it's too complicated, then you get stuck into it. So you have to go stepwise. So the innovation need not be very complicated. It can be a very simple one, and you have to always think where you are going to get your material from. So why this initiative was taken? Because we had a problem and we did have a solution. uh, uh, because of the fluctuating oil prices, which leads to higher fuel expenses. So currently diesel is priced at rupees 75.28 liters in Odisha, and 78.27 in Delhi, which is quite high in Delhi, and it is rising every day as of 21st June. And the university itself, the university in which I am housed, there are about 40 mess canteens running in the university, because there are about 40 hostels, and approximately 30 to 40,000 students are living in the hostels. There are diesel butties in the hostel messes. There are generator units, boiler units, and consumption is about 50,000 liters in a period of 6 months, and sometimes more. So we get a lot of oil from the university itself. We don't need to go to the restaurants. So if I am collecting a good amount of oil from the university itself, what will happen if I collect oil or create a supply chain from the entire city of Bhubaneswar, where I am there? So you can think about tier 1 cities and other tier 2 cities, where the consumption pattern of food and usage of oil is increasing with every passing day. And we are still relying on petrol and diesel, which is coming from crude oil. And we know that the prices keep on fluctuating, and the burning of such fuels is not good for the environment. So there are several applications. You can use it in a lantern, for cook stove, for diesel bhattis, for boiler unit at KISS. So KISS is a university for tribal students, and there are 30,000 tribal students who live there, eat there, get medical facilities, education almost free for them. And every day food for 30,000 students is cooked for breakfast, lunch, and dinner. So how do they cook all these meals? They have big boilers which are diesel fired, and they have a big kitchen, mega kitchen, which was also featured on National Geographic. There is a program on National Geographic called Mega Kitchens, and they featured the kitchen of the boiler unit at KISS, where they prepare food for 30,000 students, morning, afternoon, dinner, evening. So there are, it can be used for vehicular transportation and as well as for university generators. So this is about KISS, where the boiler unit is there. And it uses biodiesel, which is generated from waste cooking oil, where there are 3 state-of-the-art mechanized kitchens where food is cooked there, and there is a lot of energy consumption. So Kalinga Institute of Social Sciences, it was initially part of KIT, and now it is a separate world's largest tribal school, which provides accommodation, study, food, and healthcare to 25 to 27,000 tribal children. And this is now a very a famous organization, which gives education and makes tribal students self-sustainable for life. Now, from the outcome of this particular project, which helped us to create an entrepreneurial journey to develop a bioenergy unit, there was a lot of cost changes and outcomes which we could get out of this project. So one of them was that the byproducts were glycerol. So if you are converting 100 liters of waste cooking oil, so how much amount of biodiesel will you produce? So the conversion is almost 90%, which means out of 100 liters, you will have 10 liters of glycerol, and the rest would be biodiesel. So the conversion ratio of the biodiesel from the waste cooking oil is 90%. And the cost of that diesel is about 35 to 40 liters, 40 rupees per liter. and the current price of diesel is 75 per liter. So the entire process of generating biodiesel is no emissions, green chemistry. You don't have any kind of burning or anything. It's a totally a chemical reaction, and the whatever byproducts are being produced, they are all getting used. So you get biodiesel, you get glycerol, and glycerol itself has a lot of industrial uses. You get floor cleaners, which can be bottled and used, and there is generation of electricity. So basically it is a sustainable, environmentally sustainable fuel which can be used as an alternative to diesel. So now we are looking at the upscale to produce biofuel at the state level. For this, we are currently doing a lot of supply chain management. For the pandemic, we are right now stopped, but later on it's going to start. So we are also improvising on the fuel additives to improve the efficiency of the biodiesel, and also supply chain management, which can be done at state level. So we want to do it at a smaller level first and then try to go on a big level. So Government of India also has started an initiative which is called as RUCO, R-U-C-O, which is repurposed used cooking oil. So there are different centers all over India where whenever you have waste cooking oil being produced, you can deposit it at a center. So Government of India is creating banks of waste cooking oil so that people who want to use it for conversion into biodiesel can do it, and then they can have a bank of alternative fuel which can be used either for blending within diesel, or you can directly use B100 as well for your own purpose. So for this, the acknowledgements are for School of Biotechnology, for Dr. A. Samantha, who's the founder of Kit and Kiss. He's a very dynamic person, and now he is a member of Lok Sabha as well. He provided us a lot of inspiration and motivation for doing this. And we are also associated with Kit School of Mechanical Engineering, which helps us do a lot of testing of the biodiesel which we produce in their engines. So they have cars, they have diesel engines, different types of modified diesel engines, where they can test the biofuels which we are producing. If we produce several batches of different types, with additives, without additives, etc. So additives can be any enzymes or any kind of chemicals or catalysts which will increase the rate of reaction and decrease the time for conversion of biodiesel. So there can be a lot of innovations within that process as well. So this is the second part of my story. And now I'm going to focus on the third part of my entrepreneurial journey, where I diversified completely into a full-time entrepreneur. So I opened a startup, and the name of my startup is Kriya Food and Beverages. So it's quite already, you might have seen that I started from working inside the laboratory on microorganisms, and then from microorganisms I diversified into biodiesel on energy, and now I diversified into food and beverages. What am I doing? Initially I also didn't understand what am I doing and why I'm doing it. So basically, always remember, there has to be a focus. There has to be a problem. If there is no problem, you're doing nothing. Scientists and researchers, entrepreneurs always are addressing a problem. So you need to focus on what is the problem and whether you can solve it or not. So we were established in 2015. Why did I open this startup? It was to create safe and healthy food. My startup is a bakery startup. We produce baked foods. Now you may think there is a bakery at every nook and corner of every city. You will find several bakeries and all. But are the foods which are available in the bakeries safe to consume or not? That's the question. So my objective was that I would like to create a bakery and do a good amount of R&D, research and development in a bakery unit to create safe and healthy food. So we had several ideas, and I will show you what exactly we do. So we received MSME grant for this startup, and we developed some new local products using indigenous raw material from the state of Odisha, something raw material. So flour is the basic material for creating baked foods, but we didn't want to create only baked foods made up of white flour. Already know that white flour is not very good for health. And now we have a lot of information about gluten free products, people getting lactose intolerance, gluten intolerance, irritable bowel syndrome, Crohn's disease. These are diseases of the gastrointestinal tract. Some are autoimmune in nature, some are genetic in nature, some are environmental in nature. So new changes are occurring, and then you have people who are having diabetes, people who are having obesity issues. So people are now watching what they eat, and they really are knowing whether the food, they want to know whether the food is safe or not. So earlier there was no awareness, but now the consumer assessment was done, and we wanted to do a market analysis whether there is a demand for such products or not. So we incorporated my company in 2015 and looked for investors and government agencies to set up a manufacturing facility. And finally I was able to do it. So this is my student Rahul Chatterjee, with which he's my co-founder, and he was my student in masters. So I used to teach him, and he did the project on biodiesel as well. It was just a dissertation project which I had given it to him, and he took it really seriously. And he said, once he got all the results, when he was able to make biodiesel, he said, ma'am, why can't we open a company? And that really hit me, because what am I doing being a teacher when I cannot motivate my students to really think big? I can't tell them, okay, close your dissertation and put it in the library and let some junior student read it, and then if he or she wants to do it, you can do it. But then he said, no, I think we should go ahead and we should make it big. So in the same way, my objective of making safe foods, he said that we can open a company. And then I thought, because I had a small bug of entrepreneurship in me. And so we did a lot of market survey. She's Gargi Day. She's a food technologist, and this is one of the master students associated with us at that time. And they did a lot of pilot scale study. And we have several investors. We have some angel investors. We have investors from the government of India, like NSTDBE, MSME, and we have a technology business incubator sponsored by DBT, Government of India, which helped us to create our startup, where currently we are housed in a 10,000 square feet equipped facility, where we have state-of-the-art infrastructure and semi-automated mechanized plant and machinery. So with 100 products and some 30 employees, we are currently making baked foods for the entire university. So currently we are supplying to the university all kinds of products in hostel messes, hospitality. So the university itself has about 50,000 students. And the KISS, the Kalinga Institute of Social Sciences, the tribal university, has about 27,000 students. So that we have a lot of people to eat within the university area. So now we are trying to go retail, because slowly we are taking those steps. But what is the R&D we are doing? What is the problem statement which we are referring, and where is the innovation? Baked food, anyone can make a bread. But where is the innovation? So here I would like to show you a small video.
Did you know that presence of a food toxin, acrylamide, in our daily diet is a growing health concern globally? Strict norms have been laid down by the food regulatory bodies like FDA and EFSA to reduce the acrylamide content in the product. What is acrylamide? Acrylamide is a WHO-recognized Class 2A carcinogenic compound which is synthesized during cooking at high temperatures while frying, grilling, baking, toasting, and roasting. The lack of awareness amongst consumers and their regular consumption of these hazardous processed products like biscuit, coffee, cereal, bread leads to these serious health diseases in all age groups, but significantly affecting infants. So what is the solution? Acrylate is a one-stop, award-winning, cost-effective solution capable of reducing acrylamide formation in food by up to 95%. So how does this work? Adding acrylate to the food production process converts the amino acid asparagine even before the heating process takes place. So, no acrylamide can be formed in the final product. Acrylate can be used over a wide range of products. No significant changes need to be made to your recipe or production process. Taste, appearance, and texture of the final product stay unaffected, and acrylate does not require labeling. Pilot-scale trials using acrylate and its variants are being conducted at Kriya Foods manufacturing facility. We, at Kriya, make food safer and help you choose the right bite.
So that was a small video clip on what exactly we do. So the problem statement is dietary acrylamide. So since we have a bakery startup, and baking is also done at very high temperature, and during the baking process, the amino acids present in the food uh, convert into a baked food, but it also results in formation of acrylamide due to a reaction called Maillard reaction. So this acrylamide formation is a natural process, but the acrylamide is a carcinogen and is a food toxin. So basically, what I'm trying to say is that the baked foods which we consume, or any fried food which we consume, there is a certain percentage of dietary acrylamide which we are consuming. So there is about for 50%, 45 to 50% of acrylamide in our dietary intake, and a lot of food processing causes increase of acrylamide in our body, which includes heating of milk also. There are several food additives also added to baked foods. For example, the breads which you consume or buns which you consume, like potassium bromate and iodate, which is added for improving the texture of the baked foods. And highest exposure occurs in fried baked food, potato foods, chips, our French fries, coffee, biscuits, crackers, and all of these. There is a limit to which how much acrylamide should be there in presence. So there are several problems which it could result in, and our R&D is on that. So the R&D is we make acryl aid. Acryl aid is an enzyme where we are trying to make this enzyme which has to be added to the dough which has to be made during the baking, and this reduces the formation of acrylamide after the baking has occurred. So before the baking process, the acrylamide formation is reduced due to presence of an enzyme called asparaginase, which is what is the main component present in acryl aid. So our innovation is on acryl aid, which is reduction of acrylamide from high temperature baked food products or any kind of thermally processed foods. So that's the innovation, and we have a startup, and most of our food products, we want to make them safe by use of acryl aid, so that there is no change in taste, there is no change in flavor. You can have different types of unique bakery products, and it is safe for consumption as well. So currently in the market, baked foods which are available, there are several additives which are added to those baked foods which are not at all good for health. So our aim and vision for the startup is that I want to make food safer, and whether it is baked foods or any kind of innovation within the baked food, I would like to make it safer. So we are currently in the process of obtaining a patent on development of the novel L-asparaginase, which can be used for food processing. And this, who would use this acrylate? It would be used by companies who do baking, high temperature baking. Even Haldiram, which is a famous namkeen maker in India, which is the founders are in West Bengal. We had a talk with them, and they said that we want to use it. They are ready to use it, because they cannot use their waste cooking oil. Namkeen products, when you fry them in hot oil, you cannot use that oil again, because whatever product you are frying, it will turn black, or its taste will change. So ultimately what they have to do with their waste cooking oil, that waste cooking oil has to be thrown. So we are telling, don't throw it, give it to us, we convert it to biodiesel, and use acrylate, because the acrylate will make Haldiram namkeen safe. And more the food processing industries will use it, the cost of the acrylate will also decrease, because it is an innovation which needs to be used. As it is in the bakery process, a lot of enzymes are used. We use lots of amylase, we use lot of proteases, use a lot of lipases, and so asparginase is also one of the additives which you had. So you don't need to change the entire baking process. So to develop this project, we had to generate a proof of concept. So it was an idea. The problem was that we want to make the food safer, because we don't want acrylamide to get incorporated in the food processing plan of baked food products. So they said, okay, if you are developing this idea, you need to develop a proof of concept. So a proof of concept has to be developed, and this needs to be done under laboratory scale with complete research and development. And we got some grants related to it, and then we optimize the process according to ISO guidelines, try to upscale the process in 5 to 15 liter fermenters. Currently we are still in the process of doing this in a biofermenter facility at TBI, and then we will diversify the product portfolio and stepwise develop dosages and then process optimization at pilot scale. So the different analytical tests need to be done, and then only this particular acrylate can be used according to ISO guidelines in different food products, because ultimately for anything which you add to food needs to be tested before it has to be incorporated into the food processing pipeline. So these are some of the implementation plans which we are currently in the process of doing, and later on licensing and intellectual property filing, patenting, etc. would be done. So these are our team members. This is Rahul Chatterjee, who is also a PhD scholar. This is Professor Rahul Modak from School of Biotechnology. He has expertise in protein engineering. This is me, and this is Joydeep Biswas, who is a marketing, strategy, branding, and finance person. He is from management, and we have some scientific advisors who are assisting us. So we have a team, and these are some of clicks from our startup. This is our startup facility where we develop breads and different types of baked foods. These are all from our. So in the end, in my presentation, I would like to talk about briefly about what are the challenges which entrepreneurs have to face. One of the biggest challenges to obtain funds to start the business. And I will tell you in the last part of my presentation how you can overcome those obstacles to obtain funds, how to obtain funds for business. So entrepreneurship is tough, and you have to be fully responsible for the business. So in the beginning, you are the cleaner, you are the peon, you are the manager, you are the accountant, you are everything. You have to be everything. And slowly when your team grows up, then only you can delegate work to different teams. But initially you are fully responsible for the business, because it's a serious business. So you can sometimes feel alone and insecure about making the right decisions. And that's why it's very important that you have a team. Team building is very important. And having a team helps you to discuss problems, brainstorm. You can have long working hours, and sometimes you may face uncertain income levels as well. For instance, in the current pandemic situation, we have a lot of industries and startups which are having a tough time to maintain income levels for paying their employees, etc. So I'm going to give you some lessons which I have learned from my journey, and probably they will be of some use to you. So first of all, as I mentioned earlier also, innovation can be very simple. You don't need to think very hi-fi, because many times when I talk to my students, they say, ma'am, kya sochein? What, what big we can think? And you don't need to think very big, think very simple. Always focus on problems. If you can list out the problems in every sector which you would like to know, then looking at problems, you would be able to hit upon, okay, I have a solution for this, or I can think of a solution for this. It is even a very complicated process to find what I want to do innovation in. So innovation doesn't come in a jiffy. It will always come when you are focusing or observing a particular problem. So success can come from simple ideas with a twist. So someone might have already done it, doesn't matter. Innovations are things which have already been done by someone, but you do it with some other way. You just hold the nose like this and not like this. So it's a twist with your solution, but it has to be rational, and it has to be logical, and the simpler it is, the better it is. You should test your idea, test it now, and do it now. So without brainstorming your idea, so you have an idea, you cannot just start your idea without discussing it with someone. You need to brainstorm, you need to ask several people, you need to read, you need to find out how you can, whether it is scalable or not, whether you have to work on a customer level. You have to find whether there is demand for such a product, what is the market competition, and whether it is a disruptive idea, or it is a incremental idea. So this process will result in the best estimate of how the product might fare. So sometimes whatever is your initial idea, it might undergo several levels of changes in that entire process. And this feedback, you have to constantly live with that idea. And when you get feedback from someone, you modify that idea, and then you get feedback from other, you modify that idea, and then slowly the idea becomes a new thing which has a lot of weightage as well. So you polish your idea by constantly discussing and brainstorming. So an idea cannot immediately come into reality in a short span of time. You need to brainstorm, you need to talk, you need to ask questions, you need to be curious. Now in the current situation in the world, you need to think for short term. Short term doesn't mean one day, 1 month, but it can be 6 months. Don't make plans for 5 years, because 5 years is too long. If you make any plan for 5 years, then probably in 1 year things change, and whatever you have thought, and it doesn't work in the next year. So after one year, the entire plan which you have made, it fails, and then you had not made any plan B, and so you need to change, and you need to change, and it burns you out. So it's very important that you make realistic short-term goals and then try to work on it. And then you need to be adaptable so that you can change your process or your idea in such a way that you are able to stick to it. For example, we do make things to do list which you want to do the next day. You can make a things to do list which you want to do after 1 month or 1 year. And slowly and steadily, when things change, you cut out those things from your list because you think these are not realistic ones. So in current scenario, landscapes change very rapidly, and you have to learn to adapt to current rapidly changing situations. For example, a very good example is the COVID pandemic. Whatever worked before the pandemic doesn't work now. You have to change. You have to change, and you have to make plans to it, realistic ones, so that you can stick to it. And that's why you need a team where you can discuss all these things. Entrepreneurship is a difficult area. I confess that. I have gone from being a researcher and turned into an entrepreneur. It's a difficult area, but it is very rewarding also. You need to put in long hours. As I told you, you are peon, you are accountant. Initially, you are everything. You are a multitasker, and so it's kind of easy for women, not easy, but women are multitaskers, and entrepreneurship is also a multitasking job. So you need to put in long work hours, and you might have to sacrifice a lot of social uh, meetings, etc., and miss out on a lot of fun because you have to do meetings and you have to plan out for something else. So doing business is not an easy job, but you need to keep time for everything. Otherwise, it will lead to a burnout, which is disastrous. So you have to learn to manage time, take breaks, and socialize, and spend time with your family and friends. This helps you clear your mind, clears the clutter, and you can think afresh or do a little bit of meditation, etc. Now, you have to also think that being an entrepreneur is doesn't mean that you have to only think about your own idea and you have to be cutthroat businessman or businesswoman. You have to also be looking for opportunities to help people. If you, in the process of being an entrepreneur, you have done or achieved a lot, or even if you have not achieved much, but you are in a capability to help someone, you must help. But don't keep that expectations that someone will help me. Sometimes someone will help you, sometimes someone will not help you. So don't expect anything in return, but think that whatever I want to do, it should be with a clean heart, and your vision should be very clear what you exactly want to do and why you want to do. If you are not able to answer this question, why I'm doing it, then it's not advisable to go into that area. So you must focus on your skill. You should not be jack of all trades and master of none. You may be good at everything. It's good for managing people, but then if you want to uh, go into one direction, you need to focus on what you are really good at. So don't try to be good at everything. You keep yourself abreast with what is changing industry practices. Your skills should be updated, and you should be known for your skill. So when you have polished your skill, then you can polish a single product, a single service, which is more better in that particular area. And then from there only you can build it out there. So these are some of the lessons which I have learned from my journey, if they are helpful for budding entrepreneurs. So lastly, you do celebrate some small wins if you have, and be happy about it, that at least I have been able to do something. So don't lose your sanity that things are not working, this is not happening, that is not happening. These are part and parcel of everything. So you celebrate whatever small things you win. Now, since I am at KIT University, we have a technology business incubator, which was established in 2009, and they develop very good benchmark at regional, national, and global level. And now KIT TBI is recognized as the best technology business incubator by Government of India in 2018. This award was given in 2019, and it is considered as one of the best university incubators in India, as well as in global level. It comes under top 25. So the point of me telling you is that KIT TBI has developed a lot of support facilities for budding entrepreneurs. And they have several thrust areas. These are some of the thrust areas, and these are some of the startups which are housed at KIT TBI. They have a lot of advisory support. They have funding support. They have network and access to different funding agencies and market investors, etc., infrastructure support, and legal and compliance support, which is IPR, accounts, etc. So basically, if you have an idea and you don't know how to go about it, it's very difficult to do everything on your own. So you need experts. You always need experts to guide you properly, and they will help you to take steps step by step. So you need to keep on updating your knowledge in the new area. So this entire incubation means that you incubate your idea in a setup which provides you support of all different kinds and handholds you to become an entrepreneur. So technology business incubators, they do that. So they have several programs in incubation level, like training, how to make a business plan, revenue model, proof of concept, how to develop a lean startup, then how to get involved, how to get mentorship, and then what to do in investment, how to increase your level of investment. And when you learn all these things, then you start accelerating and then you scale up. And at every level there are steps which you need to know more about it. And so you need to learn a lot of business terminology, you need to know a lot of uh, business acumen, what kind of training do you need. So they provide you with mentorship, as well as they provide you sources of funding, etc., and handhold you to develop into a startup. And then when you graduate out, you can get out of the technology business incubator purview, and then totally make it on your own. So the annual turnover of the incubators has gone up to 100 lakhs and above. And there are about 31 incubators currently in KIT TBI, which are having a revenue annual turnover of 10 to 30 lakhs. So these are the different support systems for success. And these are the different funding platforms which KIT TBI is currently enabling startups to get. So if you have an idea and you don't have a proof of concept, so at the ideation level, if you are just a student, in fact many of you faculties, you have students, and they bring you ideas, they tell you, ma'am, we have an idea, sir, we have an idea. And you don't know anything about that idea, you may not have information about everything, but you can suggest someone that I know, someone that who can give you some ideas about, or brainstorm, or give you mentorship on a particular topic. So suppose you are able to give that mentorship, but if you have an idea and you need to work on it, you need to bring money. Without money, nothing is possible. That's very important. As I told you, the challenge an entrepreneur has to face, you have to bring money. So where do you bring that money? And everything starts with an idea. So at ideation stage, you have SIP fellowship and EIR fellowship. These are innovation fellowships which students can avail. And prototype, or if you have a small idea and you want to develop a prototype out of it, so you can have a proof of concept or prototype grant. So MSME, BIG, Biotech Ignition Grant, and Prayas grants, these are proof of concept grants. These can be availed by faculty members to start their entrepreneurship journey. You can just try to get or enter into how you can learn to get these kinds of grants if you have very good ideas about making it big in the entrepreneurship area. So once you develop the proof of concept and you can develop it into a prototype, workable prototype, then there are several types of grants like Tide, Mighty, GST, TDB, NSTDB, Nidhi. All these grants are slightly higher up in revenue, in money, and these grants can enable you to set up your own startup. And these grants are at commercialization or scale up level, where you can be doing testing at a larger level. So everything starts with an idea, proof of concept, prototype, validation, pilot, scale, and market. So these are different types of funding platforms which government of India has developed, and a technology business incubator gives you support to develop into a lean startup. So the whole process of innovation is initially a service. You want to introduce a new thing, and for developing that particular new thing, you need to develop a business model. Ultimately, everything comes whether you can generate money out of it. So you can have innovations which can be disruptive or breakthrough or outcome driven or organizational, and or they can be incremental. You could be developing a product or you could be developing a process. So these are different 9 different types of innovation which your startup can fall into. You can be developing a product, you can be developing an outcome, it can be a breakthrough innovation, it can be an organizational where you're trying to organize a team and giving out a service. You can have a business model. So you can have different types of innovation. And the most and the very important point in how to innovate is first find a problem. You can solve a problem, keep a notebook. You don't have you don't need to think that the problem needs to be very big. Start niche, go wide, talk to lots of people. That's very important. You need to brainstorm, go to the epicenter, go to places where such kind of problems are being solved, get motivated, and then motivate others. So these are the 3 keys to success: aspiration, inspiration, and motivation. And when you have all 3, then only you can have success. An idea does not work unless you do. And innovation is just a state of mind. It's the way you think of problems. So you can make a problem turn into an innovation, but you have to have the way you see it, see the problem. If you think a problem is a problem but not a solution, then you are not innovating. But for every problem, if you see it can be converted into an innovation, then you develop a state of mind of being an entrepreneur. So thank you very much for listening. I hope I have been able to convey my thoughts, and it will be of some help to faculties who would like to go into the arena of entrepreneurship. And I would like to also mention in the end that being faculties, you are leader makers. Faculties make leaders out of students. So you have to incorporate in them the thought of how to become leaders. So there is just one thing which I would like to mention. Please tell your students that you can become a leader if you do things which are right consistently. Anything which you do consistently is what makes you a person of character. So if you think positive every day consistently, your state of mind always remains positive. So infuse positivity into your students, ask them to be innovative. And how to be innovative? You tell them innovation is a state of mind. Thank you very much for listening. Namaste.